So this is problem 63 from chapter 20. The problem reads, a 14 ohm coffee maker and a 16 ohm frying pan are connected in series across a 120 volt source of voltage. A 23 ohm bread maker is also connected across the 120 volt voltage and is in parallel with the series combination. Find the total current supplied by the source of voltage. Alright, well, first things first, we need to be able to understand that the coffee maker, the frying pan, and the bread maker all represent resistors because they're all pulling energy from the power source. So they are going to be our respective resistances, R1 being the 14 ohms, R2 being 16 ohms, and R3 being 23 ohms to represent the coffee maker, the frying pan, and the bread maker respectively. And here I also wrote down the given voltage they gave us, which was 120 volts. But this problem is mainly to work on our manipulation of or understanding of equivalent resistances. So when you have resistors in series, their equivalent resistance is simply going to be to just add them up and take their sum. It would be R1 plus R2 plus R3. So have you, and when you have resistors in parallel, their equivalent resistance is going to be 1 over R1 plus 1 over R2 plus 1 over R3, etc., and then take their inverse value at the end of that. But in our case, the problem states that a 14 ohm coffee maker and a 16 ohm frying pan are connected in series across a 120 volt source of voltage. So that means, first things first, we need to get our equivalent resistance of our two resistors that are in series, which are R1 and R2. So to figure that out, we just simply take their values and add them together, so we get an equivalent resistance of 30 ohms. Next, the problem says that a 23 ohm bread maker is also connected across the 120 volt source and is in parallel with the series combination. So what that means is we're going to take our resistance value of the two in series, and we're going to now use that as one resistance, and we're going to use that in parallel with the third resistance, which is the bread maker. So we add those two values together. So we have our RS, which we now know is 30 ohms, and R3, which we said was 23 ohms. We add these values together, take their inverse, and we get an equivalent resistance of 13 ohms. So RP equals 13 ohms. So this is their resistance of parallel. But I also dubbed it RE for the next step of the problem, just so we can keep it straight. RE being the equivalent resistance. So in the last step, it asks us to solve for the current delivered to throughout the volt source. So we use Ohm's law where V equals IR, but you see here that I have the R being the equivalent resistance after we have condensed everything here, and we're solving for our current. So we can solve for our current by taking the voltage over our equivalent resistance to get a current of 9.22 amps.